So today we're going to cover section 6. We're going to learn the last two shortcuts for proving triangles congruent. Today they're going to be Angleside angle and angle side. The first one is the Angleside angle congruency postulate. For this Angleside angle congruency postulate, if two angles in the included side of one triangle are congruent to two angles in the included side of the second triangle, then the two triangles are congruent. So you'll have the two angles and it's going to be the side connecting them. That's the included angle. So if I were to write a congruency statement for this picture here, I need to match. The order matters. So if I just start out by saying angle, and I'm going to write them as I match them. So let me go ahead and put the congruency symbol. So I'm going to write letter A first. So if I see A has one little mark, I'm going to come over to the other triangle and see where the single mark is, and that's angle D. So notice I put them first in the first spot. Then I'm going to go to the next angle. It doesn't matter which. I'll go to B. And then B doesn't have a mark, so I'll come over here to the angle that doesn't have a mark, and that's E. And then lastly, I'll go to the C that has two marks, and then I look for the angle that has two marks in this one. So this would be my congruency statement, and I can show that these are congruent because of angle, side, angle. So ASA. That would be the reason in your proof. Next, the other shortcut we're learning today is the angle side congruency theorem. And what this one states is if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of the second triangle, then the triangles are congruent. So it cannot be the side in between it, because if it was the included side, then it would be angle side angle. So notice the position of the S. Notice it's away from the two A's. You put AA and then the S. So if I were to write a congruency statement for this figure, I would again start with my triangle symbol, the congruency. And if I looked for the first mark, G, and then one that had the single mark here is K, then I could go to the H that doesn't have anything, and it'll match with the L, and then the J that has two, and the M. It doesn't matter what you start with. I could have started out and said, I'm going to order my first triangle as JHG. Then when you go to write the second one, the order of the letters would matter, and you would write MLK. So as long as the letters match, it doesn't matter what you're starting with. So H would match with L, and then the G with the K. And again, you would be using angle side. It is not the included side. It's the non-included side of the two angles. The next slide has a summary of all 5 shortcuts. So we've learned 5 methods. The first one we learned was side, side, side. So we have to show that all 3 sides are congruent. Then we learned side, angle, side, and that's when 2 sides and the included angle are congruent. Then we learned hypotenuse leg. We can only use this shortcut for right triangles. We have to first establish that we have a right triangle. Then from there, make sure the hypotenuse and one of the legs have a congruency mark. Then the 2 that we've just learned are angle, side, angle, and angle, side. Remember, there is no ASS or SSA, and there is no AAA. So none of those. Those are not shortcuts. First example is a proof. So let's go ahead and write down the given. So first I'm going to list everything that's given. As I write down my given, I'm also going to mark my picture. So angle X is congruent to angle V. So I'm going to go ahead and put this in here. And then I'm going to say angle, the next given is angle YZW is congruent to YWZ. So I'll add a congruency mark there. So YZW is here, and YWZ is here. Bless you. Then the last piece of given is that XY is congruent to VY. And this first reason is given. Now, the triangles that I'm trying to prove congruent are XYZ and VYW. All right, so now if you look at the red and the blue triangle, notice they have an angle that's marked and a side. I need to get another piece of information in here. Now, I can't really tell anything about segments, but I could sort of tie in that I have a linear pair here. Notice right here, to get a marking perhaps on this angle and this angle, I'm going to use my linear pair postulate. So I'm going to state that this angle here, XZY, plus this one over here, equals 180 degrees. So that's my next statement. I'm going to state that angle XZY plus angle YZW equals 180. I'm going to do the same thing over here and show that this is a linear pair. So I'm also going to state that angle YWV plus angle YWZ equals 180. And this is the linear pair postulate, LPP. So linear pair postulate. Now that I've established that they both equal 180 degrees, I now can set them equal to each other, and my reason would be substitution. So step 3, I'm going to state that angle XZY plus angle YZW is equal to angle YWV plus angle YWZ, and that's substitution. The next thing I'm going to do, because I need to show, my goal here is to show that this angle equals this one. And remember, this angle is the XZY, and this one over here is going to be the YWV. So what I'm going to do now is another substitution, because I was told at the beginning up here that this angle was equal to this one. So what I'm going to do is I'm going to change this angle and make it this. I'm going to do substitution. So I'm going to rewrite it as XZY plus YWZ is equal to YWV. I'm just rewriting the right side. Is equal to YWZ. And again, substitution here. I now can use my subtraction property of equality, and I'm going to subtract this angle from both sides, leaving me with angle XZY is equal to angle YWV. And this is the subtraction property of equality. Now I've got my two angles and my side that I need to prove this congruent. So now my last statement is going to be my triangle congruency statement. So triangle XYZ is congruent to VYW, and my reason is going to be angle, angle, side. So I've shown this angle here, and then the side. So AAS. It's not the included side. Next one, I'm going to write down the given as I label my picture. So one is JL bisects angle KLM, and angle K is congruent to angle M. So K and M already have the mark. Here is KLM, and it's been bisected. So that's going to tell me that I'm going to get this angle congruent to this. However, I need to state that in my proof. So that's going to be my next statement. So this was given. So I'm going to state now that angle KLJ is congruent to angle MLJ. And this would be definition of an angle bisector. Next, I'm going to show the reflexive side, and I'm going to show that JL equals JL, or is congruent to. And this is reflexive, not reflective. And then the last statement is my congruency statement, that JKL is congruent to angle JML, and my reason would be angle, angle, side. So notice I go from an angle to the non-included side. Now, we can use any of the 5 shortcuts we've learned for this slide. This one, the first one, I'm going to add some congruency marks here instead of just angle measures. So angle 15, congruent to angle 15, and angle 150, congruent to 150. So which shortcut can I use here? Angle, side, angle. Good. So it's the included side, that's why it's angle, side, angle. The next one, I know it's not a little box, but they're telling me that this is 90 degrees here. So right away I can see that I have a right triangle. I can also see that my hypotenuses have marks, and so do my legs. So I can show that these two triangles are congruent by hypotenuse leg. And the last one, I've got a vertical, I could use vertical angles here, and then I can show that this is congruent by side, angle, side. Side to the angle to the side.
Wait, is it called, it's called...
Now the little abbreviation, the side is in between the two angles. So see how this side that has the mark is in between the two angles.
Okay.
That's how you can tell the difference.
And why would number 3 not be angle side?
Why it wouldn't be angle, side, angle?
Or I'm sorry, not angle side angle, like side angle.
Because there is no side, side angle. Because remember, side, angle, or ASS is not a postulate. So that's why it's angle, side, angle, side. One, it's a proof. So again, we're given that FAB is congruent to GED. So let me label that. It's outside here. So let me write it in the given. Angle FAB is congruent to angle GED. There's a typo too here. In this, change this angle here to say EDC. So that's the next thing I'm going to label. ABC congruent to angle EDC. So let me label that up here. And I'm also given that AC is congruent to EC. Here and here. So now, I'm going to do the same thing I did in the other one. Notice I have a linear pair here. Over here. So now I'm gonna establish that the two pieces, do the angle addition, show that they equal 180, do a substitution, another substitution, and then I can show that they're congruent. So first thing I'm gonna do is show my linear pair postulate. So I'm gonna show that angle, this in yellow so you can see it better, angle FAB plus angle CAB equals 180 degrees. So I'm saying this piece plus this piece is a straight line. I'm going to do the same thing over here, this piece plus this piece. So I'm going to say angle GED plus angle CED is equal to 180. This is my linear pair postulate. So linear pair postulate. Up here, this was given. Next, I'm going to do a substitution, set them equal to each other. So angle FAB plus angle CAB is equal to angle GED plus angle CED. Substitution. Next, I'm going to go back up to what I was given up here, or the FAB, sorry. I'm going to go to the very first given, and I'm going to take out this GED and put in FAB. Everything else I'm rewriting. Because my next step after this, I'm going to use the subtraction property of equality, and I'm going to subtract out the FABs. So this reason here where I substituted is substitution again. Step 5, subtraction. So CAB is congruent to CED, and this is subtraction property of equality. And now last, I can put in my congruency statement, which is triangle ABC is congruent to triangle EDC. And my reason is angle, Angleside. And there's your last proof.